Wind terraces. They are horizontal, steep-like erosional benches formed by differential abrasion of soft and hard rock layers at consistent height. Terraces typically form in stratified rocks with alternating hard and soft layers. Wind-blown sand abrades the exposed surface at a uniform height. Softer rock layer is worn away more rapidly. Recession of the softer layer produces a steep ridge, while the hard rock above resists erosion. Over time, the successive layers may form multiple terraces along a cliff face. Wind bridges. It is a natural arch or bridge-like structures carved in rock by wind erosion, especially by the process of abrasion and deflation in arid desert environment. It is formed when wind-blown sand erodes the lower part of the rock mass, creating an opening while the upper remains intact like a bridge. A resistant rock formation stands exposed in the desert environment. Wind carrying sand erodes the weaker parts of the rock, especially where a crack on the softer layer exists. Continuous abrasion widens the lower portion, forming a hole or an opening. The harder upper layer resists erosion and remains intact, forming a bridge-like arch. Over time, this forms a wind bridge, also called as natural arch or Aeolian arch. Best example, Wadi Rum, Jordan, Monument Valley, USA, Jaisalmer Desert, Rajasthan regions of India, wind windows. They are small rounded holes or openings eroded onto rock surface by wind abrasion. They are smaller than wind bridges and do not always pass completely through the rock. Wind windows may evolve into wind bridges. Wind-blown sand targets small weak spots like a crack or a softer layer on a rock surface. Continuous abrasion by the sand enlarges this spot into a small circular hole. The hole may grow deeper and through the rock, eventually becoming a wind bridge if it penetrates fully. Notches and fluting. They are the minor Aeolian erosional features formed on exposed rock surface in arid regions due to wind-driven sand abrasion. These features represent small-scale sculpting of rock by winds. Notches are shallow recesses or grooves cut into the base of the rock faces or inselbergs due to the abrasion action by wind-blown sand. In desert areas, wind carries sand particles close to the ground up to about 1 to 2 meters. These particles strike the lower part of the exposed rock surface, abrading and undercutting the base. Over time, this creates a concave halo or a notch, especially on the windward side of the rock. The area above the notch remains relatively unaltered because sand particle does not rise high enough to abrade it effectively. Notches are usually found at the base of the rocks, cliffs or boulders. Over time, due to the action of the wind, the notch may widen and eventually cause toppling or collapse of the rock mass. It helps in identifying dominant wind direction in desert environment. It is common in desert regions such as Thar Desert, Sahara, Colorado Plateau, USA. Fluting are narrow elongated grooves or channels etched into the surface of the rock due to sand-laden wind abrasion. When abrasion of the sand grains strike a rock surface, they remove tiny fragments of materials. If the wind direction remains constant, it carves out parallel furrows or flutes along the flow path. These grooves become more prominent, creating a corrugated or fluted texture on the rock surface. Flutes are in alignment with the wind direction and are usually in a linear parallel manner. They vary in length, depth and spacing depending on wind velocity, sand content and rock hardness. Fluting is more pronounced on softer rock like sandstone. Wind fluting can be seen in Jaisalmer sandstone formations in Rajasthan, Monument Valley in southwestern USA and Atacama Desert in Chile. Studying wind erosional landforms is crucial because it deciphers past and present climate conditions, signals environmental degradation and desertification. It helps in sustainable land use and soil conservation. It also aids in infrastructural planning in fragile environments. It supports archaeological site preservations. It acts like climate feedback mechanism and helps in understanding of surface dynamics. It promotes geotourism and environmental education. Summary. Wind erosional landforms formed are not just barren or lifeless desert features. They are active, evolving landscapes that tell the story of the Earth's wind-driven surface processes. Their study is fundamental to understanding desert geomorphology, managing fragile dry land environments and addressing the challenges posed by climate variability and human activity. Mastering the concepts related to wind erosion is crucial to appreciate the forces shaping our planet and contributing to sustainable environmental solution. The study of wind erosional landform enriches the field of geomorphology by highlighting the intricate relationship between atmospheric dynamics and terrestrial processes. It fosters interdisciplinary connections with climatology, soil science, ecology and environmental studies, preparing the geography to analyze complex natural systems holistically.